This video is going to explain the concept of feedback loops and how we can use it to model and explain climate change cause and effect. First, I'm going to very quickly discuss what a feedback loop is and how it works. Really, it's very simple. It's basically a continuous system or an equation that uses its own output as an input. Let's look at this example. Here's a really simple loop. We've got one block that tells us what to do, which is to add together the values of our two inputs. These inputs represent what we're putting into the system right now. The output of this block is also called y, the same as one of our inputs, but this is its value in the future. So let's start looking at 0 seconds on the timeline. We're going to make x always equal to 1, and y will start at 0 because there's nothing there before 0 seconds. This means that our output, y in the future, equals 1. If we scoot along the timeline to 1 second, we know that x is always going to be 1, and we know from our previous work that y at 1 second is also 1. This means that y at 2 seconds is 1 plus 1 and is equal to 2. And this carries on and on. We'll come back to this in the next video for some important concepts around control, but all you really need to know from this bit is that feedback loops are just systems that use their own output as part of their input. Let's run through one of the key examples that taught me about climate change feedback loops. Industrial activity in the Amazon and its impact on indigenous populations. This block represents increased industrial activity in the region. This can represent any number of potential industries, from cattle to crop agriculture to logging. Let's focus on a single strand and watch as it splits out in multiple routes and ultimately loops back round to feed the industrial activity. With increased industrial activity, there is going to be more industrial pollution. Runoff, leaks, exhaust, that kind of thing. This leads to the pollution of habitats over time, the severity of which depends largely on the type of waste being deposited into the ecosystem. Local plant life health is impacted within the ecosystem and will suffer stunted growth, not grow at all, or even concentrate toxins within themselves. When plants become affected, if they are eaten as a cultivated or foraged foodstuff for local indigenous inhabitants, the plants become unusable. This restricts food sources for indigenous people. Being unable to provide food from traditionally accessible sources increases economic pressure on indigenous people in the region. And of course, the largest stable employer in the region is likely to be the industry that is causing the pollution in the first place. So indigenous people will seek integration into the capitalised workforce. Having a ready source of labour with potentially few other options allows for increased industrial capacity. Ending back up where we started, feeding into an increase in industrial activity. And so the cycle continues. This is just one thread of the loop, however. Let's take another look at what happens when plant life health is impacted. Plants in the Amazon aren't just used for food. Many are used as traditional sources of medicine. And when those plants wither or become unviable, traditional medicine sources are restricted. This leads to a knock-on impact on indigenous people's health, as they cannot treat injury and disease as effectively. And when health is impacted as a result of a lack of access to medicines, this feeds right back into economic pressure. And just one final thing to illustrate how intensely interconnected climate change causes and effects are. If indigenous people are not receiving adequate nutrition, say from restricted food sources, this also has an impact on their health. It becomes very clear that the introduction of even just one thing, the increase in industrial activity, produces an impact on the local environment, people and culture through multiple consequences. And these all interact with each other to cause further issues. It's a chaotic system, but one we can model in abstract. We should always be aware that it's easy for people to get lost in the details. There's an overwhelming amount of information out there, and if we try to get everyone to understand everything all at once, people will just shut it out. Not out of malice or ignorance, but a sort of self-defense mechanism. Our own lives are complicated enough, why invite in further complexity? Fortunately, this model lends itself well to abstraction. We can group causes and effects together, simplify the model, and choose which parts we break out into more detail to get the message across more effectively. We can start out discussing the topic in detail with audiences. We can look closely at local decisions that the audience will be familiar with, things that they can relate to. Purchases, shopping habits, transport habits and the like. And where this connects to a wider network, such as international trade or climate systems, rather than going into every scientific or economic mechanism, we can generalise so that the audience gains a broad understanding of how their personal decisions propagate. Finally, in order to truly impress the message on the audience, we can expand the detail again at another part of the loop. Typically, this would either be consequences that illustrate a detrimental effect on other human beings, allowing the audience to relate to another person, or consequences that have a detrimental impact on them, allowing the audience to realise that their own actions can circle back round. So we see the potential benefits of presenting climate change's global impacts as a system of loops. It allows us to control the amount of detail appropriate to different audiences, and it always reinforces the point that our actions come back to affect us in some way. In the next video, we'll look at a very powerful feature of feedback loops: the ability to control whole loops by influencing only a few variables. I'll see you there in video 4, Threading the Needle.